Great. And record to cloud just in case. Okay, let me start us off. Well, we'd like to welcome everybody to this workshop, which is called How to Create a Currency Management Application and Deploy It on a Hyperledger Fabric Network. As with all Linux Foundation meetings, this is held under the Linux Foundation antitrust policy. If you have any questions about these matters, please contact your company counsel, or if you're a member of the Linux Foundation, feel free to contact Andrew Updegrove of the firm Gesmer Updegrove LLP, which provides legal counsel to the Linux Foundation. And this is also held under the Code of Conduct for Hyperledger. Everyone's welcome here. We appreciate all of you joining us today, and we really appreciate our three presenters, Arne, Angelo, and Marcus, who are going to do such a great job. I'm going to put some links in the chat. The chat is open. If you have questions, you can put them there. I guess, Angelo, let me know. We might make natural breaks in the presentation, but also if you're the co-presenters want to answer a question they see in chat, feel free. And I will turn it over to David Boswell for 1 second. David, you're up.
Sorry, I was just unmuting and having my screen come back on. So thank everybody for joining. I think we'll have more people joining as we go, but we welcome you. As Sean said, we welcome any questions. This is intended to be an interactive learning session. So thank you for joining, and thank you again to the speakers. If you've missed the earlier workshop that happened earlier in the year, we'll drop that in the Zoom chat as well. This is somewhat of a 2-second part to the workshop we shared earlier, so we'll drop that link as well. But that recording is available. This will be live streamed and recorded as well. And again, this is meant to be an opportunity to learn more about Fabric and what's going on in the Hyperledger community, and we welcome you and thank you for your time.
And with that, I'll turn it over to the team.
Very good. Let me start then. Sharing my screen. It should work smoothly. I tried already before. Let's see. Okay, that's good. Let's go full screen. I hope you can see my screen.
You look great. Looks great.
Very good. Thanks a lot, everyone. Thanks a lot, Dave and Sean, for organizing. I'm very grateful. I know that I reply with a lots of delay sometimes, so I'm very grateful for your effort in organizing all this. Thank you so much for everything, and thank you everyone for joining our session and also for watching later the recording. I really appreciate your spending your time with us today. So today's session is, as David said, is just a kind of a continuation of the first part that we did before. It was very more, if you want, theoretical. We described the framework of the setting. And even today, the first part will be quite short, but we will reintroduce the main concept. I will talk about the central bank digital currency, and then the second part, the longest one, will be all dedicated to a deep dive into the token SDK and how we can build a simple application for a currency management. And with the goal, with the question for us will be: is it really that easy to do, or is it really that simple to put together an application for potentially a central bank digital currency application? I'm Angelo De Caro. First, sorry, I should have introduced myself. I'm Angelo De Caro. I'm a senior technical staff member at IBM Research Zurich in Switzerland. I'm one of the architects of Fabric, and I manage for IBM Research the effort for central bank digital currency. Today with me there is Markus Brandenburger and Arne Rutsches. They will introduce themselves when it's time for them to jump in. Okay, very good. Let's start. A few logistics, just a few links that I want to put here. The first two, you will see already in the chat, but the second part, the one on Discord, if you want to reach us on Discord, I think it's also it's even better than the Zoom chat, because there we have a history, so we can keep track of your questions and the answers, and if we don't manage to answer right now, we can follow up after, because we have the history of the transaction. The messages. This is the link of the server, but you can find easily on internet, and the channel is the Fabric Token SDK. So please take your chance. It's either the chat here on Zoom or on Discord. We will keep monitoring both channels so we can address as many questions as possible. All right, agenda, the goals. The goals are very important for today, for today's presentation. Of course, we want to have again, we would like to have for you at the end of this presentation to go back home with a basic understanding of central bank digital currency, to learn what's the token SDK, what's the purpose of this framework that IBM open sourced for everyone, and also we would like to start you with a journey with the token SDK. So see how to develop your first application for token for currency management. Of course, we want also our hope is that you will like it so much that you will also come back, contribute to the project, and make it very interesting for the Hyperledger community. The agenda, as I was saying before, we'll start with an introduction. I promise, very quick. I will not bother you too much. And then Arne will jump in and we'll have the deep dive into the token SDK. I hope the menu is good enough for you. And let me start with the introduction. Actually, I wanted to show this picture again. This picture I took when it was probably last year in Dublin, when we had the Hyperledger Global Forum. So I was going to the venue and I saw this there. Use cash, keep your freedom. That I found it beautiful from the following point, from two reasons. First, it happened out of the blue. I was not expecting to find this. I noticed by chance that there was this message there. Second, it's a very powerful message because it says that if we want to introduce a new tool, a new way to implement money in the society, this tool must give must guarantee high privacy guarantees, and also freedom, that always the possibility for the end user to choose how they want to manage their money. So for me, this was a really crucial message to. Yeah, your technology must be not only very good, but it must be something that the people can trust, can believe in. So I hope that we're doing a good job. The future will tell. But let's all keep in mind this, right? There are people that are skeptical. They have the right to be skeptical, and we have the duty to answer their questions and to make sure that everything is fully understood. So now, I want to start. Usually, there are many ways to talk about this kind of system, currency system. In most of the cases, you will hear that the blockchain is involved in a way or in another, and for very good reasons. Right, blockchain is a good technology for this kind of application, because you have many parties who have conflict of interest potentially, and they find a huge value in having a common ledger where the list of transactions is fully tracked and is trustable by anyone. Now, why this is convenient? First, having a synchronized ledger means that it's easy. You don't, essentially, in most of the cases, you don't need any reconciliation, so it comes handy to have something like this. It also simplifies the process of establishing a new commercial relation, right? Because there is already a source of truth that is shared, and this can be very helpful to bootstrap quickly an activity. Now, this doesn't come for free. There's no free lunch, we know. So there are the fact that there are all these mutually distrusting participants means also that there is a concern about privacy, right? In the information that is with respect to the information stored on the ledger. So it's nice to share, but only with the people that I want to share with. So here the challenge is really to combine transparency with privacy and scalability. And in a case like a central bank digital currency, we also have to add to the picture regulatory compliance, and also the fact that you might have inhomogeneous regulation around the world. So we have to make sure that that the law is respected and the regulation is respected, meaning that the central bank can deploy their policies as the country as they decide to do. So it's an interesting intersection between requirements that might seem even contradicting to each other. Transparency and privacy, they might be at odds to each other, but actually there is a way to make them live together. And as I said, 25K, it's an important number. It's not a small number in terms of transactions per second. There needs to be final. That's important as well. So processing 25K transactions per second, it's not enough. They must be final. This transaction is almost instantaneously. The latency that the system requires, it's usually very low. It's around seconds. So that's it's very challenging in practice, especially to keep this running 24/7. That's one of the challenges. Let me just present you a very high level, a typical architecture for central bank digital currency. You have, in most of the cases, not always the case, but in most of the cases, you have at least two tiers. You have tier one, where the central bank essentially lives, from which they deploy their policy. They can perform the limit, they can enforce limits. They can have an extra bookkeeping for special purposes. Even identity management. That's definitely something very useful. In such a way, we can have a clear identification of users across the board. I know identification means also privacy violation. So we need to deploy identity schemes that support full privacy. And then we have a tier two, where essentially there are multiple networks, different kind of networks. As I was saying before, we don't expect that there will be a single network that will rule them all. Will rule all the other networks, or will prevail over all the other networks. But we might have different networks, potentially with different technology, not even necessarily all decentralized. Some of them might definitely be fully centralized as a backend. So in this case, it's very important. Also, another aspect that is very crucial in central bank digital currency is the ability for this network to interoperate. Now, just a small jump forward to say that we will not touch in this presentation interoperability, but the token SDK supports also interoperability. This might be actually, Sean, David, might be a third workshop where we focus on interoperability among different central bank digital currency networks.
Yeah, that's a great idea.
That can be very interesting. And of course, at the end, there are the users, the consumers with their wallets facing these different networks. They might have multiple requirements like portability or programmability of currency. That is what before I was saying. What's the best technology? We don't know yet, because it depends on the requirements, and the requirements are still evolving. So that's something that remains to be seen. There are other aspects, like, do we want to have only online transactions, meaning that both the sender and the recipient must be online, or do we want to support also offline transactions where we keep paying without having to connect? During the transaction, we only, maybe at the end of the day or after a few hours, or we have connectivity, we connect and we reconcile with the backend. There are so many interesting problems, really. Look, if you have questions, please, even follow-ups, you want to learn more about these aspects, please reach us as well on all the available channels. So just a summary, when we talk about central bank, the central bank digital currency, we care a lot about this interoperability, ability to perform atomic asset exchange. So the assets, this assets currency can flow freely over this this network, and we want also the system to be very efficient and, of course, private, to be private. So these are the three main topics. If you want today we are focused essentially on the last, if you want. So how we put in place an application that supports privacy automatically and is as efficient as possible. If I don't remember well, I think Arne will give us also a few examples of at least one example of regulatory compliance where we can introduce rules to force a certain transaction to be of a certain shape. I like for you just to I like to have this slide for you as a summary of the complexity of the entire system. On the left hand side, we have high-level requirements for a central bank digital currency. Some I already mentioned: privacy, compliance, accountability, resilience, scalability, interoperability. There are certain requirements that are really related to the governance, like the fact that the system needs to be compliant, the system must guarantee accountability and transparency, and some other requirements that are really more related to the transaction processing itself. So it's really more about the technology. The point here is essentially this, that the requirements are so many that we need a holistic approach to address these requirements all together. From the infrastructure, this is now I'm referring to the right-hand side of the picture. From the bottom layer, the infrastructure, where we might need dedicated hardware to accelerate the processing of transaction, or to make sure that the secret keys are super secure, and so on and so forth, to the platform. So where do we run our ledger? How do we describe this ledger? Which kind of platform do we use? Do we use Fabric? Do we use something else? Do we need GDPR compliance? Do we need a high scalable consensus? So on and so forth. The middle layer, where we need to face problems like not only the management of the tokens themselves that are representing the currency, but also what do we do? How do we identify people? What does it mean that a token is owned by a certain legal entity? How do we represent this? What does it mean if I lose my key? Does this mean that I lose my money, or is there a way to recover it? These are all questions that rotate around or gravitate around the identity management system. And then on top of this, we might have all sorts of application. From wholesale CDBC, which is more the intra-banking payments, to the retail CDBC, so what we are supposed to use every day, even non-fungible tokens. I'd like now to talk a little bit about this decentralized enterprise privacy that I mentioned maybe quickly before, which is it's the way we call the privacy mechanism that we would like to have for a central bank digital currency. Remember that one of the requirements is compliance, which means that at a certain point in time, someone should be able, on an entity that is well identified by the law, should have access to the information. But let me go step by step. So on the left hand side of this slide, you will see a pictorial representation of a ledger. We here report the account based and the UTXO version of the ledger. It doesn't matter; they are representing the same information. The point there is that there is a ledger where there are transactions described in a certain way, and everything is in the clear. So who has access to this ledger has all the information about what's happening there. Now, as I said at the beginning, this is not exactly what you want, because it's fine to have a common ledger, but having the information in the clear, this gives an objective advantage to a competitor, for example. So that's not exactly the way you want to implement a central bank digital currency, because there's no privacy, and I might not want to reveal who am I, with whom I'm transacting, and so on and so forth. So one natural question could be, an easy way, what's the dumbest way to protect the information? Let's use ciphertext. Okay, we can just encrypt in the information using some public encryption scheme, under some public key. I don't know exactly why, but the point is that, okay, if we now have simply ciphertext on the ledger, and now I'm referring to the middle, to the representation, to the depiction in the middle of the slides, how can I make sure, how can I infer that this transaction that is made of ciphertext is a valid transaction? What does it mean that a transaction is valid? But at least it should guarantee that this transaction doesn't create money out of the blue, and only the rightful owner is spending that money, right? These are the two invariants, fundamental, foundational invariants for any payment system. So a ciphertext itself cannot guarantee anything, because it doesn't deliver this belief that the content inside the ciphertext is it's correctly formed, it's legitimate. So what do we need? What's the tool that we need to deliver this belief that the transaction, despite the fact that the transaction doesn't reveal the actual content, but it at least delivers the fact that it's a valid transaction. So the tool in cryptography, probably most of you probably have heard about it, is zero knowledge proof. Now, zero-knowledge proof is a complex beast, even though it has been already deployed. Zcash is probably one of the most famous example of large-scale deployment of zero-knowledge, but it's a complex beast. So you don't want to deal directly with zero-knowledge, but you would like to have a framework that does the heavy lifting for you. Is this enough? Not yet, right? Because we have achieved our goal of having full privacy with the ability to prove that everything is fine, so that the transaction is valid. But still, we are not achieving. We are not giving any possibility to audit this transaction to a legitimate party in the system. So the picture that you might desire for a central bank digital currency is the one on the right-hand side, where for certain entities in the system, under specific condition, the ledger can be deobfuscated. So for them, certain transactions they become clear, and they can learn what's going on in this transaction. So the third model essentially it puts together the three elements: privacy, compliance, and regulation as well. All right, it's not easy to achieve all these things, but we managed to open source a version of our framework that gives you the picture on the right hand side, so you can already play with that, and Arne will give full details about that. What's this framework that we put out? We open sourced that we use also for deploying this not only central bank digital currency application, but any application that manages token. It's the token, what we call the token SDK, sometimes also Fabric Token-SDK. I don't want to stress too much Fabric in this context here on these slides, because the token SDK can play with, in principle, can play with other backends. And indeed, as an example, we provide as a backend Fabric, but also Orion. Orion is another Hyperledger Labs project. I invite you to have a look at it. It's essentially a database with enhanced blockchain, with some blockchain flavor in it. Again, we don't know what will be the implementation of the central bank digital currency. Maybe some central banks will decide for Fabric, others for Besu, others for Corda, you name it. There are many very interesting technology available out there. Others might even go for a fully centralized system. Anyway, as far as the token SDK is concerned, the token SDK doesn't bind you to a specific backend. It supports the UTXO model for a specific reason. And all this we have done to support this decentralized enterprise privacy. And the best privacy you can achieve is in the UTXO model. Unfortunately, in the account-based model, it's very hard to achieve privacy, and you only get limited privacy. So you get privacy with respect to a subset of the total amount, the total number of accounts in the system, which unfortunately is not the highest level of privacy. So you might still have leakage about who might have done a certain set of transactions on the ledger. So it's for us at least the reason why we went for the UTXO model. It's also very flexible itself. We can implement fungible and non-fungible tokens. Another thing that I like a lot about the token SDK is that essentially it lets you decide after you develop your application which kind of privacy you want for your system. Do you want to use? Do you need privacy at all? Do you want a privacy that is based on zero knowledge? Do you want a privacy that is based on trusted execution environment, right? Who knows how? Or the greatest and the latest and greatest version of zero knowledge. The token SDK will allow. It's flexible enough to adjust to adjust itself and to hide the most of the complexity that comes when you handle this complex cryptographic objects. Sometimes I like to say also that with the token SDK, you write once your application and then you decide later what kind of privacy you want, what should be the backend you want to run the token SDK against, and so on and so forth. Of course, we support audit capabilities. I believe that Arne will give an example of that. As I was saying before, we have also integration for HTLC tokens, also for asset transfer, for asset transfer, right? When an asset is destroyed in a network and reappears in another network, and for this we use Hyperledger Weaver that now went in to form a Hyperledger Cacti. Very interesting project, and we have used the token SDK already in many applications. So this is it's just a pictorial representation of the type of networks that you might handle with this kind of stack. So you will have your application nodes that are essentially forming your an application node may be executed by a commercial bank or by a payment service, and this guy will be able to talk to each other to perform transactions, and at the same time they are also able to communicate with multiple networks at the same time, delivering a cross-chain transaction or a simply transaction on a single network. Let me give you just a very quick understanding of the life cycle of a token transaction inside the token SDK. So we have on the left-hand side a bunch of people. They want to perform a transaction. You might need at least one person that wants to transfer some money, but you can have also a group of people that together they want to perform atomically a certain set of transactions. So what they do, these people, they come together, they all run the token SDK. on their phone, or they might use they might use a help of an intermediary. It doesn't matter. They come together, they assemble what we call a token request, which is a way to say that they decide the list of operations that they want to perform. They collect the signatures that are required. Remember, it's important that only the rightful owners can transfer certain tokens. Who is the rightful owner? Who can produce a valid signature under the public key that is actually owning the token. So they collect all the transaction, they go to an auditor, they refer to an auditor if this is the will, if a requirement, if this is a requirement in the system, and then at some point they send this token request to a chain code in Fabric. So the chain code will do the following: it will validate the token request, and then it will convert it to a read-write set. This is just plain Fabric. There's nothing special. Now, what I want to stress is that if we are using zero knowledge to protect the privacy of this group of parties there on the left-hand side, the token chain code will receive only zero knowledge proofs, and it will not learn anything about the transaction apart from the fact that says that if the transaction is valid or not, if these operations are valid or not, but nothing else. The chain code will not learn anything else. Then we have the usual endorsement phase. The endorsers of the chain code goes back with the endorsement. The Fabric transaction then at this point can be assembled and submit for ordering, and it can be stored, can be validated after to be finalized on the ledger. Now, I do understand that all this seems quite complex in terms of a flow. Oh my gosh, there are so many steps. How do I handle this? How do we handle all the zero knowledge proof? My belief is that after Arne's presentation, you will see that you will not see anything of this. You will not. You don't have to handle any of this complexity of invoking the chain code or generating the zero knowledge proof, validating here and there. You just care about your business logic. Now, with this was my last slide. I will switch now. If you have questions, maybe we can take a break, a short break, or just for questions here, maybe. Sean, David, I don't know what you think, and then we can I can leave the stage to Arne.
I think I can just continue from here.
Yeah, all right. So then let me stop my sharing, and then I will come back with some takeaway. Arne, please.
All right, thanks. I'm Arne Rutjes. I work at IBM, and I've been working with Hyperledger Fabric for about 8 years now, which is when it became public. And the last 1.5 years also working a lot with the Token-SDK. And it's an amazing piece of technology. You heard from Angelo already how flexible it is and what you can do with it. But there was one thing missing, I think. If you look at the Token-SDK repo, which is open source, it doesn't give you an application right away. So it took me quite a bit of effort the first time to actually get it to work. Which is why I decided to create this sample application that I will share right now with you. And you should be able to see my screen now. All right, so indeed, that all sounded quite complex. And it is because the Token-SDK is doing a lot of the heavy lifting. But I have something here that can get you started very easily. This is a new project inside of the Fabric samples repo. So you can just clone it there and you can get going. So I'll first start with just showing the basic features of this sample application. And then we're going to dive deep into what the Token-SDK actually can do and how it all works under the covers. I'm doing this full screen, by the way. So if you have questions, Marcus, maybe you can highlight them whenever the moment is right. Then I can answer them when they are there. All right. So we have 3 roles in this basic network. We have the issuer, which is an institution who can create tokens. So in the case of a central bank or a CBDC, this would be a central bank. We have the role of an owner, who is someone who can own tokens, transfer them, redeem them. Redeem is just to burn them, basically. And we have the role of the auditor, which Angelo already mentioned shortly. For compliance, sometimes it's necessary that there is an organization or a part of an organization that gets to see transactions and can also enforce certain rules on it. The token SDK doesn't force you to have an auditor. It's just something that comes up a lot in practice, and it can be really useful. I'll show you later how it works. All right, just to get to some basic use. Let me see if I can get rid of this. Yes. All right. So to start, we're going to issue some tokens. Let's call them HLF. And we're going to do, let's say, 10,000. And we're going to send them to Alice. Alice is on a node called owner1. I'll get back to that concept later, but you could just see it as her bank or her intermediary that is holding her keys for her. So I'm going to execute that transaction now. And this is being executed. And then we'll see that we have issued 10,000 HLF to Alice. If I then look at the overview of Alice, then I can see that she actually owns it. Right, simple, basic stuff. Next, she might actually want to do something with it. Maybe she wants to transfer some of these tokens that she just got to Dan. Let's say 100 to Dan, who is actually at owner 2. And maybe she wants to send a message. And already, this is something to keep in mind. You can see here that this is an integer. So there is no fractionalization. The token SDK takes a 64-bit integer as the value of your token, which means that if you're doing, let's say, if you're doing a CBDC, then this would be cents. This would be €1 or 100 cents. Something to keep in mind. All right, so now we transferred 100 to Dan, and you'll see that if we look at the transactions, the transaction history of Dan, we'll see that he received the transaction with 100 HLF and the message that Alice sent him. All right, all good. Now, you don't have to answer this out loud, but how many transactions would you think you would see now for Alice? So we had the issuance and then we had the transfer. Well, the answer is actually 3. And the reason for that is the UTXO model. Each transaction deals with a token, and a token has a certain value. So at the initial issuance, Alice got 1 token with the value of 10,000. But then when she wanted to send that to Dan, she actually had to consume that token to spend it and create 2 new tokens. And one of them is going to Dan with the 100 that she actually said. But you can see here with the same transaction ID, we have another output that is actually her change that goes back to Alice. Now, this is just how UTXO works. And if you build an application on this, it might look confusing to your users. So you might want to filter this out or something. But I thought it was good to just show it as close to how the token SDK is doing this as possible. Right, so that's what it can do. We also have the auditor. As mentioned, they get a view on all the transactions. Not mandatory for token SDK, but could be useful for compliance. And they get the same kind of Oh, this is just an example. Same kind of overview. So LSS0 EURX, but she probably has some HLF here. Well, that's it. Super simple. If you're now underwhelmed, if you think this is just, it doesn't look so complicated, then I've done my job. Then I'm really happy actually, because there's a lot going on in the backend here. And that's what I'm going to show right now. Are there any questions for now, Marcus, that I should take, or shall I continue?
So there is indeed one question. So Zakshi is asking, wait, now the shit jumped. Is there any ORM kind of system integrated with the application? So I guess ORM is object relational mapping.
Right. Well, so there is a REST API. As you can see, this is the definition of the REST API. The token SDK stores things as well. There's a local database for the UTXO transactions and, well, also all the proofs related to that. But I'm not sure what you mean exactly with an ORM system integrated with this. It's just a simple REST API, so you could integrate it with anything you like. You could build a front end on it, or there's all kinds of tooling where you can even generate things automatically based on this definition. So, yeah, it's up to you how you want to use it. All right, so let's take a look at what's actually running here. So this is it's all running in Docker. This is just a simple. This page is a simple front end, but actually there's 4 different instances of the application running. So the auditor is a separate application, the issuer, and there's 2 instances of the owner application. That's basically the stuff on top here. And then here on the bottom, we have a simple Hyperledger Fabric network and also running the token chain code. And in a diagram that looks a little bit like this, so Angelo already showed you, you have kind of a network of applications running the token SDK who can talk to each other to create transactions. And then they all have a Fabric user as well to be able to eventually submit the transactions to the Fabric network, which will execute the token chain code for validation and then commit the transaction by which moment it would be final. I'm going to show you how a transaction actually works as well. But before I do that, you can run this yourself. Just to run this, you don't need a lot of experience with Golang or whatever. You do need to have Golang installed, so there are a few prerequisites. You can find this by just git cloning the Fabric samples repo, and the link will be shared as well. You need Docker, Docker Compose, Golang, Git, nothing special. After you've done this, you should download the Fabric script again and install the Docker images and the binaries. Oh, excuse me. And the reason for that is that we're using the Fabric CA 1.5.7. So if you haven't done that in the past month or so, you'll need to get a new version. And that's because we're using the IDMix identities that the Fabric CA can offer. Actually, if you look at this screen, there's a CA running, or it doesn't have to be running, but there's a CA responsible for the accounts on these nodes. And the CA is not in any way related to the Fabric PKI. It's just that we use the Fabric CA because it has all the IDMix users available. So the CA is basically only responsible for the token network.
Arne, there
Yeah.
are questions related to this REST API. The questions are essentially, is this REST API provided or supported by the token SDK itself, or is this more on the application layer?
Yeah, this is the application layer. The token SDK itself is responsible for the communication between the different nodes, and also all the logic needed to do all the clever stuff with the tokens and the zero knowledge proofs and the Fabric transactions. So it's doing a lot of the heavy lifting, but this REST API is just an application layer wrapper around it that you can now find in the Fabric samples repo. And you can, of course, you can create your own APIs, you can create your own application. This is just a kind of a sample or a starter. If you would like to create a prototype or create a demo, or just if you want to learn more of how the token SDK could behave in a real setting. Okay, so after you've downloaded the Docker images and the binaries from Fabric, you have to make sure that these binaries are also accessible in your path, and you can check that by running Fabric CA client version, and that should be 1.5.7. That's it. Oh yeah, there's one more thing. There's a tool called TokenGen, which is actually part of the Fabric Token SDK, as you can see. And that generates the configuration for the token chain code. And that includes being able to verify signatures of the issuer and the auditor. So it's including those public certificates in there, and all the cryptographic parameters that are needed for the zero knowledge proofs that the organizations are going to create. So for now, you just have to know that you have to install the tool. And if you've done all that, you just run this one script and you're good to go. Then you're at the same point what I just showed you. To make it a bit more clear what's going on, I'm actually going to tear it down right now and show it step by step, building it up. Because there's a few steps going on here. It's not too complicated, but if you run it like that, then you'll see the different layers better as well. All right, so we're going to start with creating the identities, and there's quite a few identities going on. If you've worked with Fabric, you're probably used to all the certificate management and the keys. This is no different. Each node, so the issuer and the owners and the auditor, has its own identity. They use to communicate securely with each other. And all the users, obviously, the accounts also have their own ID mix identity. All right, so now I'm gonna just run a script. Nothing special here. This is just using the Fabric CA client to register all these users. So you can see, for instance, Dan as a user will get his own ID mix credentials. And then up here we might have FSC owner 2. This is the name of the owner 2 node. That also has its own identity. And there is also the auditor, for instance. We have, here, the issuer. The issuer has a public identity. So for them, we're actually using a normal public key and cert, because we're supposed to know who is responsible for creating all these tokens. Right. Now we could bring the CA. We don't really need it, but I'm just going to keep it running. Now we're going to create this TokenGen output. And this is actually creating a file in the token chain code folder. And that's going to be baked in there so that the token chain code can do all the validations that it needs to do. Okay, those were all the identities. And now, for those of you familiar with the Fabric sample network, this is nothing special either. We're just starting a basic network with a channel called my channel, and we're going to use that to deploy the chain codes. And that is this second step. I try to stay as close to the sample network as possible. Of course, you can easily just deploy the token chain code to any other network and configure your services to use identities on there. So this is going to take a bit just to be approved. After this is done, I'm going to copy all the keys of the organizations and the Fabric users of the sample network to a local folder here. So this will be here in the keys folder. And these are just the peer organizations. Yeah, again, nothing really special here, but this is the way we can connect to the network. Okay, well, this is already removed. That's it. So now we have a Fabric network running. We have identities for all of our FSC nodes and all our token users. And then all we have to do is just do Docker compose app, and we're good to go. And Docker compose app creates one instance for each of the roles and the Swagger UI, which will then also be accessible in your browser. All right. Now, if you're ready, let's look at what actually happens during a transaction. We still have this open, and I'm gonna open a few consoles here just to track the logs. The auditor, the issuer, and both of the owners. So it's not really about the details here, but I just want to show that there's actually a lot going on in this simple transaction that's happening. So yeah, let's just do the same thing, issuing 10,000 HLF to Alice. Right, did you see that? Issuer moved, then the auditor got to do something, and we saw something happening at the owner as well. So all these services, all these nodes are actually talking to each other to make this happen. And I'm going to show in detail what that actually is that's happening. But for now, it's just good to know that when the issuer issues, he's going to ask for an identity, and well, we'll see. I'm going to show you. And then let's do a transfer, because that's the example. So now we expect to see something happening in owner 2 as well, which I have here on the right. And it's coming from owner 1. So let's see. And final. So it's all committed on all the sides. Now, what's actually going on here? This is all in the README, so you can easily run this at home and try it yourself. So we transferred 100, well, HLF in this case, to Dan on owner 2. And what's happening here, this is the transfer view. And all of these views actually correspond to code as well. So if you're doing this at home, just take a look at where this is all going on. We have the owner. So in the service directory here, there's a transfer.go, which contains the transfer view. Looks like this. And when this gets called, we're gonna get the wallet, LSR wallet. We're gonna look for the identity of the auditor. I'll show you with the diagram, that's easier. So the transfer view, we also have the accept cache view. So to be able to accept cache, we actually need to share this identity. This is one way of making sure we have privacy. Instead of using Dan's long-time use identity to own tokens, Dan, or rather the owner2 intermediary, is going to create a one-time use key for him that is going to own this token. It's also going to create a secret, just a random string for the zero knowledge proof commitments that Alice is going to make. And by knowing this secret, both of them, they can actually, well, Dan will be able to see what Alice is doing. So Dan shares this one-time use key and the secret with Alice. And then Alice creates her transaction. So remember that she needs an input. So in this case, she'll use the just issued 10,000 HLF. She'll select that one and then create the outputs for it. She'll assign the ownership of the output to Dan's new key. And one of the outputs actually is the change that goes back to a new key that she creates for herself. She generates all the proofs. Lots of zero knowledge proof magic going on there. And she signs it and shares it back to Dan. Dan can then verify, did she actually send the amount that she promised? Did she actually send something to me? Is it actually to this key that I just shared to her? And if that's all good, he stores a pending incoming transaction in his database. And then sends a signed response back to Alice. Now Alice is ready to get the endorsement from the auditor. So this is where we could enforce business rules. For instance, we could have a transaction limit. Maybe Alice is not allowed to send more than 100 HLF. Maybe Dan is not allowed to hold more than 1,000 HLF. This could be a place to validate that. Because the auditor, Alice also shares the secret with the auditor. So the auditor is actually able to unpack these commitments and validate based on the actual contents of the transaction. If the auditor is happy, they send back a signed response. And then we're back to Fabric. So on the right, we have the Fabric peers and orderers. This is when Alice just wraps the whole token transaction into a Hyperledger Fabric transaction and submits it to the token chain code. And the token chain code validates it. Now, you might remember what Angelo said about privacy. The token chain code does not really get to see all that stuff that the auditor saw or that Dan and Alice saw. The auditor sees one-time use identities owning a certain amount. It doesn't even know how much. It just validates, is this token spent before? And are the outputs valid and are all the signatures there? So you have full privacy as a user, as an organization versus the settlement layer. I think that's pretty cool. So after the peer endorsed it, we can actually submit it to the orderer. Orderer creates a block and broadcasts it to everyone, well, to the peers. And every token SDK instance, every service will actually have been listening for this and update their local representation of the transaction to confirmed. And we're done. Dan now owns the token that Alice has sent him, and he can do with it what he wants. Any questions, Marcus?
Well, Angelo and me are trying to answer them on the fly.
Oh, great. Just feel free to interrupt me if there's anything you want me to answer. Okay, one more thing. I want to show what's actually going on the ledger. And for that, I included the Blockchain Explorer, which just released their version 2. There's a bit of configuration here, but because we're using the Fabric Samples network, it's actually really close to the original. And if I remember correctly, I can just do Docker compose up from this folder. So if you don't know the Explorer, this gives you a view on what's actually going on the ledger. And I thought it might be a good idea to show what's going on the ledger, also to prove that there's not a lot that the settlement layer can actually see. This. It's the standard username and password. All right, so we have a few transactions that just happened here, and actually it might be good to also show the ID. So let's say the last two transactions were E47 and 0E0. If we look at the API here, the transfer was 0E0. So the transaction ID you see here is also the Fabric transaction ID. And that was the transfer. Well, and then the issuance, if it's still open, yeah, that would be the E47. Okay, so let's look at the transfer and what actually happens here. So there are a few writes going on. And I think those are the most interesting. So this is the token chain code, which is writing a few things. There is a new token created here. And as you can see, the ID of the token is actually the transaction ID with an index number. Very simple. So this is a UTXO. This is what it looks like. There's another one that we're creating. So one of these is the change that is going back to Alice. But we don't know which because it's all zero knowledge. And then this is the input token. So as you can see, this has the same ID as the issuance that we did earlier. And this token is now deleted. It's spent. So this is how the life cycle of the token basically goes. And then we have a big one here. And this is called the token request. And this basically describes all the actions that Alice performed. And that looks a little bit like this. Copy script. No, that's not right. Okay, let me check. I think if I copy it well, then okay, what if I store it as a JSON then? There we go. All right, so this is what a token request actually contains. So again, we have here the input token. We have the commitments that basically prove that Alice is allowed to do something with this token. And then we have the output where we have two new tokens, which I also just showed on the ledger. And then there's a whole part for the proof here. So that is kind of how it all works. So we've seen now the different components that are running, how they communicate, what actually happens during a transfer, and what a token looks like and what's actually written to the ledger. Now, if you want to use this yourself, either you just run it like I just did, but I really hope some of you are also now inspired to actually build something on top of this. Either build your own application, or you can change it. You can add APIs. You can take a look at the code. It's actually fairly simply structured. So you can also add your own features. For instance, the Token-SDK repo has an example for HTLC, hash time lock contracts, which you could use to transact in between blockchains. So it could be a nice project to add that to this sample as well. And of course, we also welcome pull requests if you decide to do something like that. I'm going to give one more example of what you could do for code, and then we can wrap up. So let's say we are in a situation where we want that only tokens of type TOC are allowed to be issued and used on this network. Now, where would you actually put a control like this? We have many places where we're doing validations and stuff. So you could think maybe we want the issuer, we just block the API or do something like that. That's a bit of a naive approach. Maybe you want the owner, maybe in the accept view, maybe you want to put some code there that says, I don't accept anything else than TOC. Well, you can. In the accept view, you get access to the transaction. So this is what happens when someone sends a transaction to you. So first you respond with the identity, but later you actually get to store the transaction. So we're doing a few checks here already. There should be some outputs, and there should be some output actually going to us. So you could easily just add something here as well to say, I don't accept anything smaller than 1, smaller than 100, or I don't accept whatever. It's up to you. It depends on your business logic. But I think, so yeah, oh, you might think maybe we do it in the token chain code. Well, then we have a problem because the token chain code doesn't actually know so much. It only validates signatures, basically. So then a logical place to do this would actually be the auditor. If the auditor doesn't approve a transaction, it doesn't happen. It doesn't get approved by the chain code either. So let's do that. I'm going to do Docker compose down and show you how you would do that. So here in the service, we have the audit view, and this is where all the logic is. Okay, a lot of it is abstracted away because it's actually taken care of by the token SDK itself. But this is also where you would add business logic. So there's a link here, and I really encourage you, if you really want to dive deep into this, that you also go to the Fabric Token-SDK repo, because there's a lot of documentation there, and also example code. So this one is a sample from the Fabric Token-SDK for the auditor. And they have some interesting examples here, like payment limit. You may not send anything more than 200. Cumulative payment limit. Many things you could actually try out. But for now, we actually only want to check, is this the right type? So there's something here, apparently, where we have token types. So we might actually be able to use this. So let's get the outputs. Auditor.audit. So the auditor is basically reading the transaction here. auditor is reading the transaction. We don't need the inputs here. If there's an error, we actually want to whatever. And now we want to use these outputs in outputs. And here we can take a look at, you can do many things. You can look at the sum, you can look at, well, anything you want. You can inspect them here because the auditor actually gets clear text access. Let's say we expect only one type, return now the magic. If outputs dot token types 0, because there's only one. If it's not TOC, we're gonna fail this transaction. Something like this. It's a stupid example, but at least you get the idea then. So I'm gonna build that. So if you want a quicker way of developing, the README also specifies how you could run this natively. So you just do go build, and then you can go much quicker. You can also attach a debugger or whatever you want. But just Docker Compose is just simpler to get started in the beginning. Oh, there's a mistake here. If no, yeah. If output tokens, yeah, many mistakes. The length should be 1. Right. This looks better. All right. Well, what we should see now, the auditor view is invoked whenever someone issues or when a transfer happens. So this is probably a good enforcement point. Let's see if we can try it out. If we can transfer some HLF now. No, we can't, because failed auditing. Well, it's a bit behind the thing here, but you can see that it says only TOC allowed. And then hopefully if I issue some TOC, it will actually succeed. Taking its time. Okay. I don't know what's going on here, but you get the idea. Interesting. Okay, well, I issued some talk to Dan at least. So talk is allowed. Can I send something to Alice? Oh, well, I'm gonna look into that. Anyway, oh, there we go. With all this, hopefully, you now have a good idea of how the token SDK can actually work in a sample. And I really hope that some of you will now go and git clone the Fabric samples and experiment with it yourself. Because, yeah, as you saw, actually starting it is pretty simple. You just clone it, you install the dependencies, and you get to run the application and try out some applications. But there are many rabbit holes to dive into, and many things you could actually build on top of this. So yeah, I hope you liked it, and I hope you start to use it. And I really hope that eventually some of you will even look at the Token SDK repo and contribute to it. Angelo, do you have any final words?
Maybe I can share the last slide, just a summary, take away from the entire discussion, and then I don't know if maybe we can open the floor to questions, live questions with voice. So a few takeaways, and also then we will open to questions. So the Token SDK was our effort, mostly for us, first and foremost for us to deploy quickly token-based applications on Fabric. This at least at the beginning was the goal, with this ability to this flexibility in choosing the kind of privacy guarantees we needed, and it quickly evolved to something more complex that even it's agnostic to can work against other backends. It adopts the UTXO model because the UTXO model seems the one that it's best suited to achieve very strong privacy guarantees, but also high throughput, right? Because when I'm spending the only reason why you might have a conflict generated by two transactions is because they are trying to spend the same output, which anyway is something that you want to avoid. So you expect a conflict to appear. Otherwise, transaction can be committed in parallel. It uses a very simple token definitions for two reasons. Simplicity, it's always a good design principle, and it's also because applying zero knowledge to more complex definition can be very challenging, and leakage of information can become unmanageable. So that's the reason. But so far, what we've seen, this very simple definition with this simple operation of issuing, transfer, redeem, it's enough for most of the applications that at least we faced. We are really looking forward for your feedback for the application you might want to want to develop with the Token SDK, and see how we can extend the framework. As you have seen in the code doesn't really speak any Fabric language. You don't see there any reference to chain code or any other Fabric concept, proposals, and stuff like that. You also don't see zero knowledge right there. You just see a high level, something that is close to the business logic, because the Token SDK does the rest of the heavy lifting. And we want it to be like that because these crypto objects are very complex to manage. If you don't do properly, then you have you might easily have breaches, security breaches, or leakage of information. So that's the best way to encapsulate this logic, so that it's easy in case of bugs to find them and fix quickly. Again, the token SDK is there. I forgot to add the link to the labs. Sorry for that, but I think in the chat there are these links as well. Please reach us on Discord if you want to know how to participate and how to contribute to the token SDK, or if you want to learn more in general about this technology. And with that, I thank you all really. And yes, we can have questions. I don't know how does it work, this Sean, David?
So Angelo, if folks still have questions, they can ask them in the chat. We've also posted the link to the Discord a couple of times. Everyone's welcome to go there as well. And this entire session is being live streamed on YouTube. It will also end up on the Hyperledger YouTube channel, along with all these links. I'm going to make sure the links from this session are in the YouTube page as well as on the wiki. And someone asked about the presentations. So from our presenters, if we can get a PDF of those slides, I'll make sure they're on the wiki page for the workshop as well. But thank you to the three of you. This has been a fantastic workshop. If folks have questions, please ask them in chat.
Yeah. Also, let us know if you are interested in another session where we can show the interoperability aspects of the token SDK. What does it mean to perform asset transfers after asset exchange and so on and so forth. This can be another session for you if you are interested in that.
Any chance we can get to do another workshop with you, Angelo, we're going to take. So that's let me go get the calendar. But for the folks who are attending, please, if you have questions, please place them in the chat.
The transcript will be in the YouTube. Okay.
So there's one question in the chat. Does this application use offline transaction signing?
Offline transaction signing. What do you mean with that? That you take the transaction, you go into a dark room where you are fully disconnected, you produce the signature, and you come back. Is this a yes for?
This is a yes. Well, I believe so. In this sample we showed today, we don't demonstrate any offline signing capabilities. So all the interactions we saw using the Swagger API were basically then directly invoked on the Fabric samples test network.
Oh, themselves. Meaning, for the example where, for example, suppose that there is a commercial bank. Alice has an account in a commercial bank that is managing the tokens for Alice, but you might still want that Alice produces the signature. Yes, you can do that. We are extending even the public version of the token SDK to support that, but that was not in the example. So maybe this can be an additional argument. An additional subject for another presentation, or we show how you can do that. Yeah. So can I use the token SDK to develop a single CDBC application? Yeah, I guess that was the purpose of the presentation today. Of course, a CDBC implementation, a CDBC solution, it's a very complex beast because the requirements are very heavy in terms of privacy, availability, scalability, and so on and so forth. So this is just an example that we have given you. Then you need a full stack. You need to optimize throughout the full stack to get a real solution.
So Maria is asking, could the sample with the ETH token also be used? So this example is really using UTXO and the token SDK for that, but that's again where the interoperability comes into play. So I'm actually working on a demo where you could do a transaction, an HTLC transaction with an Ethereum network as well. And lots of the projects that IBM is doing with central banks or commercial banks or other institutions actually have that feature of interoperability as well. Yeah. And then it gets really interesting, of course.
So Jim, I don't know what you mean with the API level interoperability. We have API. The token SDK has API that will hide the fact that there is cacti behind as a framework for the actual interoperability, because again it's token driven. I don't know if you what you meant that exact. So we usually try to hide the lower level API. Yeah. So they are not cacti. You will not use directly cacti. You will not see cacti. You will have an API that speaks about the fact that you are preparing an asset transfer or an asset exchange across networks. Yeah. In offline transaction side, there was one before. In the future, we want to expose. We do interest. In offline transaction signing, user key and certificate will not leave user machine. Nobody else will have user keys. Yeah, that makes sense. What are the challenges from your point of view for Fabric to be used by the ECB context or the CDBC use case? Even this is quite a broad question. The point certainly is that the vanilla Fabric as it is, someone said, has very low throughput. So I said this also in another presentation. We are a little bit delaying the publishing of the paper, but we are aiming in terms of throughput to go over hundreds of thousands of transactions per second. To be final. That's our target. So to be well above the 25K limits. But for now, these are just words. So please stay tuned, and we have to publish all this. That's a lot of we have a lot of goodies. Please give us time to. We need time to release this step by step. Also, the code. The code will be released. So step by step, things will happen. Using token can achieve. That's the point. So actually. It's not the problem itself of the Fabric, the token SDK. Remember that the Fabric allows you to execute transaction in parallel, right? So there it's not much the problem of the token SDK. If you have enough computational resources, you can generate many transactions in parallel. The point is at the committer that is the bottleneck currently in Fabric. So we heavily worked on that pipeline to make it fast as possible. Remember, and that's the reason why we don't support account. The problem of account is that if Bob and Charlie are transferring to Alice, these two transactions must be processed sequentially. They cannot go in parallel. But for UTXO, these two transactions can be committed in parallel, because it doesn't matter that we are transferring to the same owner, because these two transactions are creating new outputs owned by Alice. Now, this should give you already a hint why UTXO is also the best infrastructure to get very high throughput, because you naturally don't have conflict unless you are double spending, which in that case you want to catch the conflict, you want to catch double spending, and therefore you want to see the conflict. That's the thing. Can this token SDK work with Firefly easily? Don't know actually. Honestly, what's I know that the Firefly has its own token definition. It would be interesting to see a kind of being the token SDK, the provider of the tokens also for Firefly. Why not? The hardware configuration. Sorry, I might skip questions. Well, guys, jump in if I'm where I'm skipping. What hardware configuration is needed for achieving a high throughput? This depends very much on which part of the system we are talking about. So there are parts that are more disk intensive, other that are more CPU intensive, and so on and so forth. Depends where what we are. That which is also good, right? Because you know. The ordering service might require, it's very disk intensive and memory intensive, and also connectivity. You need a high IO channel, that's for sure. Verifying the zero knowledge, the committee, the endorsement, they need to verify zero knowledge proofs. So they are very CPU and memory intensive, so you need to deploy accordingly to what you need. Firefly is a more general purpose framework to the best of my knowledge. The token SDK, it's really about tokens and nothing else, and tokens with privacy. So we care a lot about privacy, compliance, interoperability. This is our focus. So we don't want to address all the possible applications. We just want this application, the applications around CDBC. I would say CDBC is our main focus, but also other token application. That's fine. The rest, that's not us. Does any provision for RBAC can we customize the issuer and multiple owner? Yeah, the issues you can have multiple issuers. I think any access policy can be put on top of the system. The only question becomes: do you need to embed additional access policy inside the zero knowledge proof? In that case, you have to touch a part of the token SDK that is called token driver. That is the one that is the part of the token SDK that is handling the complexity of the cryptographic scheme. I usually think about it as the Linux, the kernel modules. So the token driver are like kernel modules, so very delicate objects. You really need to know what you have, but then you have on top of it you have Linux. As Fab is a good usable registration app for user. Orgs with RBAC support is not. It needs, well, probably Jim. That I'm not sure if we have any good usable registration app for users. Honestly, I'm not aware. We should ask Dave Enyart for that. For code chain, I am ready in Golang. Which one you suggest with respect to the performance? JavaScript might be a bit more challenging. It depends. So if we have to execute cryptographic primitives, nowadays seems Rust to be a good language. There are Go is also very performant. Modulo the garbage collector certain times can give some can be a little bit troublesome. Yes. Any other question, Marcus? Any other question, or Arne? Any question that you have seen? We don't support account. We don't support the account-based model for the reasons that I said. You don't obtain perfect privacy with account-based model, but only privacy with the respect of the subset with respect to a subset of the total number of the accounts. You get privacy, so that's a more limited privacy. So that's it. But for UTXO, we don't need we achieve full privacy with zero knowledge. We don't use any private data collection for Fabric. We just use the basic file, the basic ledger. Nothing, no special thing.
So Angelo, there was a question by Maria asking about basically the difference between the token SDK and the Fabric samples token ERC20 sample. So maybe we can highlight a little bit.
So the two main questions, right, Maria? Sorry, two main points. One is throughput. Certainly, remember, if you are using account model, Bob and Charlie, and transferring to Alice, these two transactions needs to be handled sequentially. They cannot be processed in parallel because there is only Alice has only one account, and it needs to be updated accordingly to the transaction. But this is not the case for UTXO. And the second and very crucial aspect is privacy. So we know how to achieve the best possible privacy in the context of UTXO. We don't know how to do that with the account-based. Actually, the best you can achieve in terms of privacy for the account is, as I said, this privacy with respect to only a subset of the total number of accounts. The privacy that you would like to have is to have privacy with respect to the entire set of accounts. But if you want to do that, then the proof, the system becomes very expensive. So you need a lot of time to generate this zero knowledge proof. Sometimes you find this called anonymity set. What's your anonymity set? It's the entire set, the entire universe of accounts. It's a subset of accounts. What was that?
So for the presenters, someone asked me a question, I think accidentally instead of to everyone. What is the chance that the same token will be issued to more than one owner issuer if they both request for tokens concurrently? Is there a lock implemented?
Oh, no, it doesn't. The two transactions can go in parallel, right? Because a token, maybe this I should have said more explicitly to give a full definition. But this is in the other presentation. A token in the token SDK is a triplet with 3 fields. The type of the token, the owner of the token can be, the type can be any string. Can be the denomination of the token, but even a JSON structure. The owner of the token can be a simple public key or a script, something more complex. And then there is the quantity, which is the amount of value that is in this token. So the issuer will just create 2 tokens, possibly in 2 different transactions, but even in the same transaction, this can be done. And each of these tokens will have a different public key, for example, and therefore this can go in parallel. They can be committed even atomically in the same transaction. There is no risk of conflicts here. Okay. Again, even for ERC20, do you care about privacy, Maria? Because if you care about privacy, immediately the ERC token becomes problematic. Because how do you achieve privacy in that context, right? That's it's one of the main differentiators. Because for non-fungible tokens, maybe you don't need hundreds of thousands of transactions per second, right? You are happy with much. Maybe we can be happy with much less in terms of throughput. But the question becomes, do you need privacy? And as soon as you need privacy, the ERC20 and company becomes a bottleneck. At that point, they are more problematic. Unless you go to a mechanism like the one implemented by Starkware, you have the second layer. But again, the machinery is much more complex, and depends at that point depends which kind of throughput you want, and it's always a trade-off, right? That's the reason why for the token SDK we are really focusing. Our main application is central bank digital currency, because that's the most challenging and the most interesting for us.
Angelo, Jim asked if we can change the token definition to support controller in addition to the owner.
Yeah, beautiful question. I'm sorry, Marcus, maybe you want to answer it.
No, you answer this. I asked.
Sure, absolutely. No, we can do that already, because for interoperability, we support script. So what will be the support for a controller? It will be a script that says that either the legitimate owner can transfer this token, or a controller under a certain condition, for example. So it's all about scripting. Now, the default token SDK, we only support hard-coded scripts. Again, for the following reason, we didn't go with the support of a Turing machine or a Turing machine complete virtual machine, or a Bitcoin virtual machine, because we want to keep things simple. If there is a use case that requires more complex, the more complexity, we still believe that it's better to do ad hoc scripts, because then you need also to make sure that these scripts are well understood, it's clear what they are doing, and so on and so forth. But in principle, maybe this is an exercise for you guys, for the listener of this talk. Extend the token SDK to support the Bitcoin virtual machine in the owner field. It's doable, so that can be an exercise for you. Is it a challenge to keep track of all tokens with an increasing distribution of the token in smaller and smaller chunks in big use cases, as it needs to be searchable in milliseconds? I wouldn't be too worried about that, honestly, because there are very efficient databases. There is an issue with privacy, that you have this growing list of serial numbers. This happens also in zero cash. So for that, we need special tricks to manage this, to handle this ever-growing list of tokens. But for the other questions, I think that's not a problem. In DVP, you have ERC20 type, okay, for payment, but the asset side has an owner account. Yes, we're creating escrow transaction for DVP atomic transfer. Yeah, it's doable. I think the other session if we do the session of interoperability, then there will become. I think we will answer more questions about that. Yeah. All right. Anything else?
And we've made a note about a future session on interoperability. In the token, oh, I'm sorry, Gaurav just asked, in the token implementation, do you have an escrow mechanism?
It's HTLC, so we support the HTLC script, so that can be understood as an escrow account by many means.
Awesome. All right.
Lovely, Jim. Please share. We will support also your escrow your escrow system. There's something better than we know also the HTLC is also the basic HTLC protocol doesn't support any privacy. So if you want to have an interoperable, you want to have an atomic cross-chain transaction with privacy, then HTLC alone will leak information about the transaction. So you need the better mechanisms there for sure.
David West asks, what other chains is Hyperledger most similar to and influenced by?
David, that's the problem. Hyperledger is just an umbrella. It's the name of the umbrella project, right? It's this greenhouse. Then there is Hyperledger Fabric, Hyperledger Besu, and so on and so forth. So maybe if you can be more specific. The model exists now. We haven't coded it. It was too limited for complex DVP. Very good. Is this production ready for CDBC? So the Token-SDK, as we offered in this public version, it's on your risk to use. That's usually we don't. That's I would say the best we can offer. Right now. Oh, Fabric, you say, what are the chains is Hyperledger most similar to and influenced by? For Fabric, I would say that Fabric is pretty unique, at least at the time when we published the first paper about Fabric. I think it was among probably the first, if not the first, among the first networks to use the execute order validation paradigm that is different from Ethereum or Bitcoin, where they have execution and validation. So that probably was the main difference that Fabric brought in, which meant parallel execution of business logic and then very fast verification on chain. I believe Cardano is also order execute.
Okay, and I've added the links that we've been discussing one more time to the chat. These links are also going to be on the wiki page. We're going to have the video there. We're going to have the presentation decks in PDF format there as well. There is a workshop in mid-November specific to cacti. You can find that on the wiki page, as well as please check out the Hyperledger Discord. That's where the contemporaneous in real-time conversations are happening around these projects. There's an entire section of Fabric, and there's Hyperledger Labs lower down the channel list because we separate the labs from all the other projects. So you can check out the Token-SDK lab. You can check out some of the links that we've discussed here. I think we have time for one more question. Strubums, and it is Fabric providing support for enterprise applications?
Yes, I guess you need anyway an enterprise offering around Fabric. Then for this you have multiple providers. I think there is Oracle, IBM, of course, yep, and others that are giving you an enterprise support for Fabric directly. But yes, you can use Fabric for enterprise applications.
And David just shared the case studies link. Thank you so much for that, David. I would like to thank once again Marcus, Arne, and Angelo for putting on such a great presentation today. This is going to be on the wiki. It's going to be on the Hyperledger YouTube if you want to watch it again or share it with a colleague. And David, Boswell, and I are going to start planning an interop workshop. Hopefully with these three once again. You guys are great. And we'd like to thank everybody for joining us. And I'm going to stop the stream and we're going to end this workshop. So thank you all. Really appreciate all the amazing questions. Please join the Discord. That's where more of these conversations are happening, as well as we have Fabric calls and a Fabric mailing list.